This is part 2 of section 1.5. We've just solved quadratics by factoring. And that's a great method if what you're dealing with is easy to factor. Well, if it does factor, period. Not everything we need to solve will factor, so we need some other methods. We're going to learn 3 more methods here. Okay? The first one we have is the square root property. And what this one says is if you know that you have something squared, it doesn't have to be just a simple x, it could be anything squared. But as long as that whole thing is squared and that square thing is alone, and it is equal to something else, then essentially you get to take the square root of both sides, but on this side you have to have a plus or minus. Generally speaking, if we have a square, we should get 2 answers. That plus or minus is what gives us those 2 answers. Okay, so let's solve a couple of these. If I have 5x squared is equal to 45, I need the square thing alone, so I'm going to divide both sides by a 5. And we get x squared is equal to 9. Okay. Now, if we take the square root of both sides, we have to put in a plus or minus over here. The square root of x squared, if we're following this property up here, this is u squared, this is just u. Taking the square root of x squared, we're going to say that's x. And that equals plus or minus. We simplify the square root if we can. This is a perfect square, so it is 3. So our 2 answers are -3 and +3. Okay, so let's do 2x squared minus 7 is equal to -15. We need the square alone, so I'm going to add 7 to both sides. So I get 2x squared is equal to, that's going to be a -8. Now divide both sides by a 2, and we get x squared is equal to -4. Now we can take the square root of both sides, and remember we have to put in a plus or minus over here. So we get x squared is equal to plus or minus. When we take the square root of a negative number, we have an imaginary answer. We're going to have a complex solution here. And then we take the square root of 4. I'm going to write it out to remind you how squares or negatives work, but this is a step you probably would not normally write out in this case. This is equivalent to, not squared, that's gone, sorry. I times the square root of 4, and normally, probably, you would do the square root of 4 in your head and get plus or minus 2i. So your 2 solutions are -2i and +2i. Okay, so let's solve 3 times x plus 4 squared is equal to 21. Now this is much more like what you're going to see as we work through this course. Yes, you get some where you just have something squared, but this happens a lot more often. Notice we have something squared, and it doesn't have to be just x squared. It can be this whole thing squared. But I have this 3 in front, so I'm going to divide everything by a 3. So that will cancel out, and I will have something squared alone. So this is x plus 4 squared is equal to 7. Okay, now we have something squared equal to a number, so we take the square root of both sides. Don't forget the plus or minus. So when I take the square root of something squared, I get simply what's underneath without the square. So I have x plus 4 is equal to plus or minus. I would simplify the square root of 7 if I could. 7 is a prime number, so it doesn't simplify, so we keep it as the square root of 7. Do not give a decimal approximation in this course unless you are specifically asked to do so. Okay? Now, what I need to do still is to get x by itself, so I'm going to move this 4 over to here. I'm really subtracting 4 here, and I strongly suggest that you put this number in front of your plus or minus. You can put -4 over here, but it tends to cause a lot of problems. If you're careless with how long your radical bar is, something like that, it can get really confusing. This is just the safest way to write that side. Okay, so my two answers are -4 minus the square root of 7, and then -4 plus the square root of 7. Okay, so let's do x plus 2 squared is equal to -7. Okay, this is already something squared by itself equal to a number. So let's take the square root of both sides, remembering the plus or minus. So what I have over here on the left is x plus 2, and this is going to equal plus or minus. It's a negative, so I'm going to have an I on the outside, and 7 is prime, so I cannot simplify the square root of 7. Okay, now move the 2 over to here, and we get x is equal to -2 plus or minus I times the square root of 7. This is a complex answer. This was a real answer. Up here, it would have been okay if you had changed, for example, this one to square root of 7 minus 4. This is technically the same thing. When you're dealing with a complex answer, your I always has to go last. You don't have a choice here. Your two answers are -2 minus I square root 7 and -2 plus I square root 7. That's another reason to go ahead and write it in this direction, in this order, so you don't have to keep these two separate. Okay, so we have factoring, but factoring doesn't always work. Sometimes it's really hard to factor. We have the square root property, but the square root property only works when we're given something in the right form, and we're not always given something in the right form. So what we need is we need things that are more powerful. And our first more powerful technique is called completing the square. I'm going to be perfectly honest. Nobody likes completing the square. Nobody. But there are topics, specifically circles, that we are not going to be able to work any other way. So as we go through these completing the square problems, I don't want you to think of these as, let's just get an answer to this equation, because that's not really what we're doing here. We're relearning this process so we can apply it in a later chapter, okay? So completing the square, what do we do? If we start off with a general quadratic, so ax squared plus bx plus c is equal to 0, we're going to follow these steps every time to solve the equation. The first thing we have to do is to divide everything by a. So if there's a number other than 1 right here, we have to divide everything by that. That means we're going to get fractions a lot. We're just going to have to deal with them, okay? We want to get the constant alone on a side. So whatever this is, we're going to move it to the other side. Now, these two steps, these can be done in either order. So if you have an equation and the constant is already alone, there's no reason to undo that, so you can divide by a and then move the constant back over. But these two steps need to be done in before anything else, okay? Now what we're going to do is we're going to find what I call the magic number. This is my term. If you go on to another course and you start calling this the magic number, your professor's going to look at you like you're crazy. So just remember that that's my term. But we're going to look for this one magic number. And to do that, what we do is we take the coefficient of x, so whatever number is right here after we've divided by a, then we're going to divide that number by 2, okay? And that you can also think of dividing by 2 by multiply by 1/2. When we have a fraction, it's easier to think of it as multiplying by 1/2. When we have a whole number, it's easier to think of it as dividing by 2. They are mathematically the same. And then after we've divided it by 2, after we've taken half of it, then we're going to square that number. Okay? And then once we square that number, that's our magic number. Now we add this number to both sides. And I know this isn't making a whole lot of sense right now. It will hopefully make more sense as we get into an example problem. Okay? We're going to add this number to both sides. We can add any number to both sides of an equation. Okay? But this particular number is the only number that will give us a perfect square trinomial on one side. We're going to factor that. And then once we have factored that, we have something that looks like the square root property that we just worked. And we're going to attempt some problems in the next part.